Hello guys, welcome to the channel Physics Breakdowns. Today I'm your host Liam, and we will be going over 1D kinematics. So first of all, what is kinematics? Kinematics is the study of motion. It's basically objects moving, right? So we have two very important concepts to start off kinematics with. The first one is time. Time is represented with a t, lowercase t, and its units are in seconds. Represented with s, but I'll write out seconds just to make it more obvious. So basically, let's say this intro took 100 seconds. That would be the time that it lasted. The next concept is distance, represented with the variable x, and is measured in the unit of meters. Distance is the position something is from a specific value. So let's say I have this little graph here, x and t. And we can just make arbitrary values like 10, 5, 1, and 2. Let's draw a slope here. So we can see that at this point, time equals 1 second. The position of the object that is moving is at position of 5 meters. We notice that this graph creates a slope. And the slope can be represented as the change in position, which is delta x, change in position, which is delta is the triangle, over change in time. It's just rise over run, right? Rise is the change in position. Run is the change in time. So now we can represent this as a new variable v, meaning velocity. And velocity is measured in meters over seconds. Meters over seconds. So, and velocity is the rate of change of position. So let's say, so basically, we know that this object in 2 seconds travels distance of 10 meters. So this object has a velocity of 5. Sorry, you probably can't see that. It's a velocity of 5 meters per second. And we can also, just like with position and time, we can create a graph for velocity and time. So we have v, we have t. So now, this object at time equals 1 second has a velocity of 5 meters per second. Now, we can also see that this graph also has a slope. Now, what is a slope? The slope is represented as the change in velocity over the change in time, rise over run. And this is represented as the new variable a, meaning acceleration. And a is measured in meters per second per second. This is also this can be represented as a meters per second squared, which is often how it's represented. So now, what does acceleration mean? Acceleration is basically the slope of a velocity versus time graph, and it represents the change in the rate of change of position. So we can say that this slope here, so we see this object accelerated from 10 to 10 meters per second in a span of 2 seconds, meaning its acceleration is 5 meters per second squared. So these are basically the 4 fundamental concepts of kinematics. as for now, we'll be simply worrying about kinematics in one dimension. Hence the name, one-dimensional kinematics. So, now that we know these 4 concepts, now we have to know the relationships between the concepts, these variables. And these are known as the big 3 kinematics equations. So the first one is as such. V equals V naught plus AT. So this relates the final velocity to the initial velocity, which is represented as V naught, or V with a little 0, plus the acceleration times the time. So next, we need to know our second big 3 equation. Now this is a bit more complex, but I'll break it down for you. That's what the channel is about. So we have change in position equals the initial velocity times time plus half of the acceleration times time squared. So this just shows the change in position using the initial velocity, the acceleration, and time. And lastly, for the final big 3 equation, we have final velocity squared equals the initial velocity squared plus 2 times the acceleration of the object multiplied by the change in position. Now all these 3 all have their importance in their own ways. And mainly, I think these 2 are the most important for you to use, because these are used in a lot of kinematics problems in 1 dimension and 2 dimensions. That will be covered in the future. So for the first one, you can easily find the change position without knowing the final velocity. And with the second equation, you can find the final velocity without the use of time, which is very important. So now we will go to 2 practice problems that will help you understand these concepts further. So take a minute to pause, and we'll go over the first one, practice problem on the left. First practice problem on the left. So pause right now and maybe try to solve it. Okay, hopefully you tried to solve it, but now I'll give you the explanation. So first, we need to know what the acceleration due to gravity on Earth is. And that's represented by the variable g, which is 9.8 meters per second squared. This value should be like memorized into your brain. This is very important for honestly all of physics. So remember that. So now with that knowledge, we can use the equation delta x equals VOT plus half AT squared. So we know that since it is dropped, we can assume that it starts at 0 initial velocity. So this value right here is 0, and can be neglected. So now we get that delta x equals half AT squared. Now if you want to solve for t, we just move the variables around and we get that t equals 2 delta x over a. Sorry, I'm bad at writing on my laptop. Okay, so since we know this, we know that the initial height, so we can draw a little diagram here. So we know it starts at a height of 100 meters, and it goes to a height of 0 meters, meaning its displacement is negative 100 meters. We also know that the acceleration is negative 9.8 meters per second squared, because acceleration is downwards, which is treated as negative in this case. So we get that time equals 2 times negative 100 meters over 9.8 meters per second squared, negative 9.8 meters per second squared. We get that this value will equal to about 4.5 seconds. That's how long it takes for a rock to fall to the ground from a 100-meter tall ledge. Okay, so after solving that, please pause the video to work on the second problem and try to work through it. Alright. So now on to the second problem. So for this problem, it is important to define what the term rest means. Rest means the car is not moving, basically. So it accelerates from rest, meaning it starts at an initial velocity of 0 meters per second. Next, we can use one of our big three kinematics equations and say that v final squared, which is just v squared, equals v naught squared plus 2 times acceleration times the change of position. So this, since we know that the initial velocity is 0, this whole value can just be ignored. That's going to be 0. So now we get that v equals 2a delta t, or v squared, sorry. By moving around some variables, or by square rooting both sides, we get that the final velocity equals square root of 2 times the acceleration times the change of position. And plugging in the 50 meters here and the 15 meters per second squared here, we get that this equals to root 2 times 15 meters per second squared times 50 meters. And this value should be around 39-ish meters per second. So yes, that will be the car's final velocity. Hopefully you learned a thing or two from this video. And next week's video we'll detail 2D kinematics, which is motion in 2 dimensions. So come back next week for that video, and thanks for watching. Bye.